Welcome back. So in this particular video, we will look at how refrigerants are being designated. See, you would have seen the refrigerants being named like R11 or 12 or 22 or 1 and 20. So in this particular video, we will see how a particular refrigerant is given that particular designation. Okay, so let me share the screen and we'll start this particular lecture. Okay, so we will look at how refrigerants are being designated. Okay. So if the refrigerants are to be designated, they can be designated based on what sort of compounds they are. Okay, we will look at compounds which are saturated. We will look at saturated organic compounds. Okay, so one example would be when I say saturated organic compounds, say let me say C2H6. So this is an organic compound. This is ethane. So in the first video, we talked a little bit on that, but I think in the video it was not clear. So let us see what is a saturated compound and what is an unsaturated compound. See, a saturated hydrocarbon or unsaturated hydrocarbon, it differs when you see when the carbon is connected only with single bond. Only when there is a single bond in the structure, in the chemical bonding between, say, hydrogen, chlorine, fluorine, whatever is there in the chemical. So if they are connected by single bond, then we call them as saturated organic compound. If the carbon is connected by a double bond or a triple bond, at least in one particular location, then we call it as a saturated organic compound. Okay, so we say alkanes are examples of saturated organic compounds, and unsaturated organic compounds examples are alkenes and alkynes. These are examples of unsaturated organic compounds. Okay, so in this particular designation of refrigerants, we will start with saturated organic compounds which are used as refrigerants. Okay, so C2H6 is one example, but to begin with, let me take the example of let's say C2Cl2F4. What is this? This is dichloro. So you have two chlorine atoms, dichloro tetrafluoroethane. Okay, so dichlorotetrafluoroethane is another saturated organic compound, and we will look at this particular example to start with. Okay, to identify whether it is a saturated organic compound or not, if I have to give them give the structure, so one particular bond is there between the two carbon atoms. So you have three more bonds available. Okay, so each carbon atom is going to have two fluorine atoms, and you have one chlorine atom for each carbon atom. So you have got C2Cl2F4. So this is dichlorotetrafluoroethane. Okay, so now how do I give a designation for this particular refrigerant? Okay, so that is the question, right? Okay, so what they do is, this organic compounds, they have carbon, they have hydrogen, and sometimes they have chlorine, and then sometimes they have fluorine. Okay, and whenever you have a carbon atom, the number of carbon atoms that is represented by M, the number of hydrogen atoms that is represented by N, and for chlorine, it is represented by P, and for fluorine it is represented by Q. Okay, so this is a general expression that you have for any organic compound. Okay, well, any refrigerant that is used as any compound that is used as a refrigerant. Okay, and when it is being represented, say for example, in this particular case it is R114. Okay, and so we will see what, so R stands for refrigerant. So what is this 4, what is this 1, and what is this one? Okay, we will look at that. Okay, and because it is a saturated organic compound, this, if it is going to be a saturated organic compound, and if it is going to be of the form CmHnClpFq, if that is the structure by which it is going to be represented, then this needs to satisfy an equation which is N plus P plus Q, and that is supposed to be equal to 2m plus 2. So what is this M? M represents the number of carbon atoms, N represents the number of hydrogen atoms, P represents the number of chlorine atoms, and Q represents number of fluorine atoms. Okay, so now if it is a saturated organic compound, then it should satisfy the expression N plus P plus Q equal to 2m plus 2. So let's try with this particular example of dichlorotetrafluoroethane. So here in this particular example, so far excuse me, dichlorotetrafluoroethane. So I'm going to have the value of M is equal to 2 because I have the number of carbon atoms to be 2. Okay, then let me change the color. So number of carbon atoms here is 2. Okay, and then do we have hydrogen atoms here? There is no hydrogen atom here, so N is going to be equal to 0. And P represents the number of chlorine atoms. So the number of chlorine atoms here is 2. So let me highlight that too. So the number of chlorine atoms here is 2. And then we have the fluorine atoms. So that is represented by Q, which is equal to 4. So we have 4 fluorine atoms. Let me take black. So the number of fluorine atoms here is 4. Okay. So now we have given the numbers for M and P and Q. So this equation needs to be satisfied if it is going to be a saturated organic compound. So N is 0, P is 2, and Q is 4. So that is your left hand side, N plus P plus Q. So that is 0 plus 2 plus 4, and that should satisfy 2m plus 2. So the number of carbon atoms that I have is 2. So 2 into 2 plus 2. So 2 plus 4 is 6 on the left hand side, and this is again 4 plus 2, which is 6 on the right hand side. So this is exactly a saturated organic compound. It satisfies the equation. Okay. So now, how do I write or designate a particular value for this refrigerant? Okay, so for any refrigerant, I'm going to have R. Okay, and you are going to have, sorry, you're going to have 3 digits here. Okay, I'm putting 3 digits over here. So for the last digit, say for this one, so for this last digit, this is going to comprise of the number of fluorine atoms. So this is simply going to be your Q. Okay, and so the number of fluorine atoms that we have here is 4. Okay, then the last but one, this is going to be n plus 1, the number of hydrogen atoms plus 1. So what do we have here? The number of hydrogen atoms that we have here is 0. So 0 plus 1, that is going to be equal to 1 over here. Okay, then we are left out with only one thing, that is the first digit. So this is going to be m minus 1. So the number of carbon atoms minus 1. So we have 2 carbon atoms. So 2 minus 1 is going to be again 1. So that is how we designate dichlorotetrafluoroethane as R114. So it is going to be R followed by m minus 1, then followed by n plus 1, followed by q. So this is how we give a designation for a refrigerant, which is a saturated organic compound. Okay, right? So to make things clear, let's take one more example. So let's say, so the second example, let's take CCl2F2. So this is dichloro, difluoro. You have one carbon atom, so it is methane. Dichloro, difluoro, methane. Okay, so you know the expression. So the expression is supposed to be CM HN Cl suffix P and F suffix Q. Okay, so now let's compare this with the chemical formula that is given. So we have M equal to 1. We have only one carbon atom. Again, there is no hydrogen atom, so N is equal to 0. The number of chlorine atoms that we have is 2. The number of fluorine atoms that we have is 2. Okay, and is this a saturated hydrocarbon or an unsaturated hydrocarbon? Let's check. We have only one carbon atom which has got 4 valence electrons, so which means it can accommodate 4 atoms. So it has got 2 chlorine atoms and it has got 2 fluorine atoms. So the carbon is attached with all the other 4 atoms in a single bond, so it is a saturated organic compound. Okay, so we have confirmed that it is a saturated organic compound. So if it is a saturated organic compound, it should satisfy the equation N plus P plus Q, that is equal to 2M plus 2. Okay, so that is the equation. So let's see whether it is satisfied or not. So N is 0, P is 2, and Q is 2. So 2 plus 2, that is going to be 4 on the left hand side. So the number of carbon atoms that we have is 1. So 2 into 1 plus 2. So 2 plus 2 is again 4. So it confirms once again that it is a saturated organic compound. Okay, so now we have to designate, give a designation for this refrigerant. So in the previous case we saw it should be R M minus 1 followed by N plus 1 followed by Q. Okay, so what is M minus 1? M minus 1 is 1 minus 1, which is going to be 0. And then N plus 1 is the number of hydrogen atoms here is 0. So we are going to have 1. And then Q is 2. So when it is 0, we don't mention it. So we just eliminate it and we simply call that as R12. So R12 is the designation for dichloro-difluoroethane. So if the number of carbon, if the first digit M minus 1, it becomes 0, we simply neglect it. We are not going to mention it. Okay, so that is going to be R12. Okay, so whenever you have a 2-digit number, that means the first digit happens to be 0, which means M minus 1 becomes 0. So that is how you should understand it. Is that clear? Okay, so that is the example. Okay, now let's do it the other way around. Okay, so let me take another color over here, and let's take the reverse order. Let me say I am given the value R22. Okay, and they with the help of this designation, find out what is the chemical formula. What is the chemical formula for your refrigerant? So what is the chemical formula for R22? Let's check that. Okay, so how do we know what is the designation? So it says it is supposed to be R M minus 1 followed by N plus 1 followed by Q, right? So it is only a two-digit number. So if it is a two-digit number, it is obviously it is going to be M minus 1 is going to be 0. So M minus 1 is 0. N plus 1 is 2 and Q is again 2. So which means M is equal to 1 and N is equal to 1. Q is equal to 2, and we do not know if there is any chlorine atom available with this particular configuration. So we should go and check the equation. N plus P plus Q, that is equal to 2M plus 2. Okay, so N we know that it is 1, P we don't know, Q is 2, and the number of carbon atom happens to be 1. So on the right hand side we are going to have 4. So we have P plus 3 is equal to 4, which means P is equal to 1. So how many carbon atoms do we have? The number of carbon atoms that we have is 1. The number of hydrogen atom that we have is 1. The number of chlorine atom that we have is 1. And the number of fluorine atom that we have is 2. So it is CHClF2. So R22 stands for CHClF2. Okay, so this is one way by which, so if the refrigerant designation is given, you will be able to get the chemical formula of the refrigerant as well. And to confirm, so carbon is going to have 4 bonds. Okay, so you have H, you have Cl, you have F, and you have F. So once again, this is a saturated hydrocarbon where the carbon is connected with all the other atoms with a single bond. Okay, so this is how we designate a saturated organic compound. Okay, now the second thing is how to designate an unsaturated organic compound. We have found how to designate a saturated organic compound. Now how to designate unsaturated organic compound. That means when your carbon atom has got a double bond or a triple bond. Okay, so let's take C2H4. So what is C2H4? I'm going to have double bond with reference to carbon. So 2 bonds are remaining. So I have one H over here, and another H over here and here. So this is my ethylene, isn't it? Ethene. Okay, so ethylene or ethene. So that is what we have here. So now how to designate this unsaturated carbon organic compound when you have a double bond or a triple bond? Okay, so in that case, the equation slightly turns to be N plus P plus Q is simply equal to 2M. So if it is an unsaturated organic compound, it should satisfy the equation N plus P plus Q equal to 2M. And also, we in the previous case, we said R followed by M minus 1, then N plus 1 and Q, isn't it? So here, when it is an unsaturated organic compound, the first digit immediately after R will be 1. The moment you say it is unsaturated organic compound, you are going to have 1. Okay, and the next digit that you are going to have is M minus 1. The next digit that you are going to have is N plus 1, and the next digit you are going to have is Q. So for an unsaturated organic compound, you are going to have a 4-digit number. Okay, so let's take an example and see how it turns out to be. Okay, the example that we will take out here is we have already taken C2H4. So let's see what is the designation for C2H4. So C2H4. Okay, how many carbon atoms do we have? We have 2 carbon atoms. How many hydrogen atoms do we have? We have 4. That doesn't change. What is the general expression that we have? That doesn't change. The general expression is Cm. Let me erase it. Sorry. Okay, I'll strike this and write. I'm not able to find the eraser. So the general expression still remains as Cm, Hn, CLP, and FQ. That doesn't change. That still remains the same. So the number of carbon atoms that we have is sorry about that. The number of carbon atoms that we have is 2, and the number of hydrogen atoms that we have is 4. P is going to be 0, and Q is going to be 0. Okay, so once we know this, so now let's go and see whether this particular equation is satisfied. N plus P plus Q is equal to 2M. The number of hydrogen atoms that we have is 4. This is 0 and this is 0. The number of carbon atoms that we have is 2. So 4 is equal to 4. So that is how we find that it is an unsaturated organic compound. Now let's designate this. So we said the moment it is going to be an unsaturated organic compound, R is going to be followed by 1. And how many carbon atoms that we have? 2. So M minus 1 will be 2 minus 1, and that will be 1 again. And then we have N plus 1. N plus 1 is going to be 5. And Q is going to be 0. So the designation for ethylene is R1150. Is that clear? Okay, so this is how we designate unsaturated organic compound. Let's look at the reverse way. Okay, so let me say I have R1120. Okay, so the moment you see it's a 4-digit number, it is going to be an unsaturated hydrocarbon. Okay, so this one stands for unsaturated hydrocarbon, and this one stands for M minus 1. This 2 stands for N plus 1, and this 0 stands for Q. Okay, so now let us write it down. So M minus 1 is equal to 1, which means M is equal to 2. Then we have N plus 1 equal to 2, which means N is equal to 1. Okay, M is equal to 2, N is equal to 1. And then we have Q is equal to 0. Now we don't know what is P. So let us write down the equation. N plus P, because it is an unsaturated hydrocarbon, N plus P plus Q is supposed to be equal to 2M. So N is equal to 1. P is what we are supposed to find out. Sorry about that. This is P. Q is equal to 0, and 2 into 2 is 4. So P plus 1 is equal to 4. So P is equal to 3. So that means number of chlorine atoms is going to be equal to 3. So the general expression is Cm, Hn, CLP, and FQ. So now if we write this, we are going to get, what are we going to get? Let me move this. Okay, I'm sorry about that. So C, number of M is going to be 2, H is going to be 1, and Cl3, and Q is going to be 0. So it is CH2HCl3. Okay, and let's look at the bonding. So you are going to have a double bond with reference to carbon because there are 2 carbon atoms, and so you are left with 2 single bonds. So in one case you are going to have hydrogen and chlorine, and in the other case you are going to have 2 chlorine atoms. So because you have a double bond, it's going to be an unsaturated hydrocarbon. Okay, so this is C2HCl3 And the corresponding designation is R1120. Is that clear? So for saturated organic compound, we have a particular way to designate the refrigerant. For unsaturated organic compound, we have another way to designate the refrigerant. And finally, there is another case which is called the inorganic compounds. What are inorganic compounds? Some examples we can see. Ammonia. You don't have any carbon over here, so it is neither a saturated organic compound or um, unsaturated organic compound. So it's an inorganic compound. So when you have an inorganic compound, you normally represent it as R followed by the first digit is going to be 7. When you have unsaturated hydrocarbon, the first digit happens to be 1. It is a 4-digit number and the first digit happens to be 1. When it is an inorganic compound, the first digit happens to be 7. And then you are going to have something over here. And what you are going to have here is the molecular weight of the compound. Okay, the molecular mass of the compound. So what is the molecular mass of ammonia? Molecular mass of ammonia is 14 plus 3, which is 17. So the first digit is going to be 7. The molecular mass of ammonia is 17. So you're going to have this as R717. Water. Water is not an organic compound, so it is also inorganic. Sorry, this is 717. So for water, because it is inorganic, it is going to be followed by 7. And what is the molecular mass of water? 2 plus 16, it is 18. So R718. What about carbon dioxide? R followed by 7. Molecular mass of carbon dioxide is 44, R744. How about air? Air is again inorganic. R followed by 7. Molecular mass of air is going to be 29. So R729. Sulfur dioxide. R followed by 7. For oxygen, it is going to be 16 plus 16, 32. And molecular mass of sulfur is also 32. So 32 plus 32 is 64. R764. Okay, so this is how inorganic compounds are designated. Okay, so if it is going to be a saturated organic compound, we designate it by saying, so let us summarize. Let me say summary. So when it is saturated organic compound, I am going to designate it saying R followed by M minus 1, N plus 1, Q. So it's going to be a 2-digit number. And if M minus 1 is going to be 0, it will be a 2-digit number with the first digit being neglected because it is 0. The second one is unsaturated organic compound. So for an unsaturated organic compound, we are going to have R followed by 1, followed by M minus 1, N plus 1, and Q. And the last one is inorganic compound. So when you have inorganic compound, it is R followed by 7 and the molecular mass. So whatever the molecular mass of the refrigerant that you have, that will be there in the second slide. Okay, so thanks for joining, and that's the end of this module on refrigerants. Thank you.